to go over the user guide and kind of start walking through some of these steps. We're hoping some of you have tried it. I know Mark from Gateway has run some different areas on it, so we're going to be asking for input. So let's get started, Jake.
All right, thanks, Dave.
Just FYI, I did press record on this meeting, so we will be recording this meeting for resource database in the MDS website so that it can be viewed at a later time.
Okay, thanks, guys. So let me share this. All right, so as David mentioned, we've had a few presentations on CEP so far, kind of getting us caught back up with this tool. We previously focused on just getting the installs done and running through, some of the basic functionality, what's in each tab, things like that, in a prior presentation. And really, any questions from the prior presentation, or as we're going down through the user guide, please feel free to ask as we're going through. I am going to be focusing on different topics than what we focused on in the prior presentation, so we're not going to really dig into a lot of the same material, but we'll just do a quick refresher on CEP background, go through any updates on install issues. Then we'll get into the user's guide with the appendices, the overview, the inputs, and then just a general review. So the cost effectiveness program, which we developed back in 2010, I believe, is an economic alternatives analysis tool. It's present worth based, looking at cost effectiveness of I&I removal, basically measuring, is it cheaper to remove the I&I versus store and or treat it. This background here, this slide gives some idea of the resources we have available on the MDS. Feasibility Study Working Group Document 13 specifically, and it's actually Appendix A in the user's guide, provides a lot of good information. I think Feasibility Study Working Group Docs 9, 12, and 13 are all look at feasibility or flow isolation studies, which feed into the CEP tool as well. The working group documents are available on MDS along with the user's guide. When you install the program, the user's guide is in the folder where the install is placed. We have updated the CEP program to be installed on today's machines, and the installer package was emailed out by Annie. So if you still need that install package, please contact Annie Quinn. So, and Glenn had mentioned there were some workarounds that some of the firms had to go through to get this install done. And I think it was Microsoft something installer package 3.5 had to be used instead of 7.0 for some, in some cases. And I'm going to talk about that. And if there are updated install problems or issues anyone's going through, please let us know so we can get those addressed as soon as possible. Now, I will say I think most of those who have attended these SSS subcommittees so far have the program installed. We had, I think, 3 individuals that had some outstanding issues, and I think we might be down to 2 at this point, that we're looking to address actually later today, individually. So it's critical. If you haven't installed this program yet and opened it up and used it, or are still having problems with that, you need to let us know. And then just at the bottom here, when we'll hit on this a few times, but the main inputs for this CEP tool are flow isolation measurements, which if you're a separate sanitary sewer community and you had for this phase 2 consent order, if you have an area that's red or purple, if you're above the gold line standard, or you're tributary to an SSO, you should have done flow isolation measurements and therefore should be using this program moving forward with alternatives analysis. Beyond the flow isolation measurements, there's model results feed into this. There's a lot of community specific data, and then there's also some information that we have a specific ad hoc committee that's going to discuss updating things like costs and effectiveness, things like that. So it's designed to develop recommendations on an internal municipal level for cost-effective solutions related to the application of I&I removal versus treatment and or storage alternatives based on present worth analysis and strictly an economic analysis that assists in answering, is it cheaper to remove RDII and GWI, which together, that when we say I&I, that's what we mean, inflow and infiltration, from the system, or leave it in and convey it to storage and treatment? And is this alternative cost effective? I just had this slide up just to, mention, hey, we went over CEP install issues previously. Just wanted to, again, say, if you're having issues with the install process, please let us know. And I guess I'll back up also mentioning there were municipalities that were able to install the program fine. It went through, but when they went to click on it, nothing would happen, or there were still some issues with the program. So if you're one of those, please let us know. So this is the cover sheet of the user's guide. It's a pretty well put together document and contains I thought all the background and information you need on this program. It's dated July 2010. There's no updates needed at this point. We've updated the installer package, but haven't changed the program at all. Sorry about that. Okay. Now, it may seem odd, but I want to start with the appendices just to show a lot of the backup documentation. And there's a lot of references in the actual document to these appendices. Here's the layout of them. Appendix A, as I had mentioned, was the feasibility study working group document 13. Appendix B gives kind of the hierarchy of the terms that are used. C and D get into different data definitions and give you guidance on the inputs for sub areas and subunits. E looks at the specific construction methods that I think are default in the program, and talks about how to add additional ones. F, and we're going to look at these, but F, I think, is just actual definitions for the input fields. G is formulas. It shows you, how this result is calculated. It's based on these several inputs, and it'll step through that. H will show you all the different reports, and I think it gets into, more definitions on some of the output. And then I gives a range for what the program expects as far as the inputs go. Whether it's a percentage from 0 to 100, or this has to be an integer value, things like that. So these appendices are really helpful when going through the user's guide. As we had mentioned, here's the overview. This is jumping into the user's guide. Economic alternatives analysis tool, present worth based, to determine cost effectiveness of the source flow reduction. Here's your base inputs. These are the base data that needs to be brought into the program. You have design storm, RDI volumes, GWI factors. That comes from modeling and flow monitoring, QA/QC, that kind of thing, storm deconstructions. Constants regarding treatment and transportation. So those are items that I think need to be discussed with the ad hoc committee. Present worth factors, and then storage values. So that's if you're, evaluating an alternative for storage, that'll be on a case-by-case basis. The construction estimates are also something to be discussed with the ad hoc committees. We're trying to get updated information regarding, costs for the different I&I removal technologies, as well as effectiveness. And then the individual subunit data that you import into the tool, and that's based on the flow isolation results. So a good part of 1 and 2 here, this base data, is going to be discussed with the ad hoc committee, specifically for this tool, as we're updating default values. Subunit data is all on the individual user and your flow isolation results. Continuing with the overview, just a reminder, we're identifying cost effectiveness, but it's based on certain assumptions, and you need to pay attention to the input fields and even the default parameters that the ad hoc committee comes up with to see, how am I getting to this solution? Again, it's driven by flow isolation measurements, municipal asset information, construction costs, and the different sanitary sewer rehab methods. This is in the user's guide and gives a good idea of how all the different sets of data all come together. And you can see, we have RCS FMP flow monitoring data. This, could be updated to contemporary flow data as well. You have your H&H model data, flow isolation measurements, working with your GIS department. Here's your full GIS or flow isolation results. You're distributing GWI by a subunit. Each subunit has, a lot of different input fields for demographic and geographic data. All that comes into the CEP tool. We'll look, the ad hoc committee is going to discuss global external parameters. We're going to input updated construction detail information, and then the CEP tool, once you have everything loaded, it runs with 1 click, and then you have your output. All right, so this is the section 2 using the CEP. What I want to highlight on this slide is really you're setting up a new sub area. We're going to have default values that are going to be used, and you have to go through each one of those, make sure they're appropriate for your municipality. The construction methods will be in there by default. You can add, subtract, however you want to do. We'll dig in a little bit more in this presentation on the options and how you set that up and what they mean. And then you're importing your subunit data, which is the output from flow isolation measurements and your GIS exercises, and hit and run. So this is just a screenshot of the tool as it opens up and the default values that are currently in there. I'm going to kind of gloss over the main construction options and subunits. I'm not going to go into a lot of detail with all those as we did that in our prior meeting, but certainly any questions we have on any of that, we can go into as I'm going through these presentations or at the end. But I'm going to focus on some specific information in the user's guide that I don't think we've touched on yet. So for this program, once you have everything loaded in, the link looking sentence here at the bottom, that's your run button. When you hit that, once everything's loaded in, and assuming it's loaded in properly, well, I guess here's your results when you try to hit run. It's going to tell you in that same location, insufficient data for recalc. So you'll know you'll have to go back in. The base data or assumptions have changed. That's what we saw here. That if you make any changes to the default values, to subunits, things like that, it'll come back to here letting you know you have to rerun. Or recalculation okay, meaning your results are up to date. Next, I wanted to talk about the difference between, your construction methods, your options, how that all intersects with each other. So the construction method itself is just the specific rehab process, whether it's trenchless, meaning your full lining from manhole to manhole, in trench replacing, digging up the pipe as it is and replacing it, or different parallel sewer options. And again, we went through those in prior presentations. I'm going to skip over those for now. And you can add additional construction methods. I think we've shown examples with manhole lining or grouting, things like that can also be brought in. Pipe bursting, we can throw that in here, and you would specify the different costs for that construction methods and the different effectiveness for removal of the I&I. The option tab, and this is what the options tab looks like. The options tab takes those construction methods that you've assigned, that you want to look at, and assigns them to the different type of subunits you have. The subunit types by default, and I'm not sure that you can add other ones. I think these are the three you can pick from: is a collector, a trunk, or an interceptor. And I'm going to go back a few slides here, but I want to touch on these first. A collector, the way the CEP tool is looking at it, we're generally small diameter, 10-inch or less. This is what's your service laterals are mainly connected to. A trunk is going to be larger than 10-inch. It's conveying flow, but still there are, maybe a smaller number of laterals directly connected to that sewer. And then an interceptor, we're almost assuming no direct connections at this point. This is a large diameter sewer that's conveying the collectors and trunks to the treatment facility or storage facility, something like that. And it's split up this way so that you can, evaluate different costs or different effectiveness of each technology, for each one of these types of sewers. And this options tab is kind of where you mix and match. You mix and match your construction methods with your different types of subunits. So you can set it up that for my collection system, my collector sewers, I only want to look at trenchless. You know, for my end results, that's all I want to look at. Or I'm going to set up an option that's specific for trenchless trunk sewer work. You know, I'm lining a trunk sewer, and that should be different than the cost and effectiveness of me lining my collector sewer. It enables you to kind of put different costs and effectiveness of I&I removal for each of these options. Yes. Yeah, you can override, you can delete options, add options. Once you get all the information into this program, you'll see that it's pretty easy to make modifications because, you know, you could just add a new option in here. It could be option 6, assign a few things to just, you know, just play around with some different alternatives, and then you hit run and your results are there immediately. It's not,
You can over lateral.
In your default values, what's that?
yeah. So the question was, you know, are you able to override, you know, different, I guess, inputs in here? It's like, yeah, sure, we have all this base data, but you can override things. Now, on your question specifically on service lateral length, I don't think you can just override that parameter.
Set up a different method and for the default value.
Yeah,
That's how you.
okay. That makes sense. So yeah, in your construction method, I think you'd make modifications there and only evaluate. Well, there'll be a new option. Option 6 is just looking at, I don't know, lining of laterals or something to that effect.
Create the option 6 and then in your subunit tab buys the length of the lateral. It doesn't take the tool doesn't take into consideration that in a specific neighborhood, this lateral's 25 feet, this lateral's 30 feet, this lateral's 40 feet. It's basically an average of the lateral neighborhoods.
Go back to the same then, average.
Yeah.
That's the default value. That average is the default. If you wanted to, in that specific neighborhood, the default value is what, 30 feet?
35 is default right now.
35.
Yeah.
If in that neighborhood that you're evaluating for that specific area, if that's shorter, then just create a different.
Subunit.
Option.
And on, okay.
And then in the subunit. Or in the default value, shorten that length up to 20 feet. Or whatever.
Yeah, or you could run an entirely, you could have, all right, all my base data is loaded in here. I'd back up this database. This is one way of looking at it. You could take that same database and start messing with that lateral length and see how it affects your results. Or if it's, hey, I only want to look at these 5 subunits. I know that they're a lot shorter, so, you know, break them out of this grouping, and then they would have their own database, and you could look at them individually. And sometimes, you know, and I'll look into that. I'll look into, you know, how can I go through a specific example of how to affect that decision. But I think it would be in the subunits, like Jason had said. So back to, all right, we talked about construction methods, talked about the options. Now, the option is your general approach to rehabbing a sub area. It's the highest level of the analysis. And on the cost effectiveness chart we see at the end, every one of those lines represents an option. And then subunit types are linked to specific construction methods for each option. Talked about the different subunit types. Now, I will say it, in my experience, it hasn't been, it's a clean or easy answer necessarily to split these up, because in a lot of cases you might have a flow isolation measurement that it had a trunk sewer, maybe it's a 15-inch sewer for 3 segments, but it's also collector sewers branch off of that. So there may be some subjective decisions in there, but I would say, you want to go by what the majority is and how that's going to, reflect on your results. Here's our subunits tab. So here's all the information we've imported from our flow isolation and our GIS exercise, things like that. We reviewed the subunit import last meeting and went over a few errors that you get, specific errors you get with that process. If anybody is still having issues with those, please shoot me an email. I can help you through it. The user's guide goes into a few examples for troubleshooting that data import. So those can be found in section 2.5.5. And kind of lets you know that you should be able to tell by the error where, in this example, the percent improved main column was input incorrectly, and you can fix the problem that way based on this code. Jumping down, I'm going to go through some specific discussion on the subunit data, the percent improved, the structure counts versus EDU counts, and what do they mean? Construction factor, things like that, and how does each one of these affect the results? So for constructability factors, this was input into the program for, kind of beyond, hey, here's my subunit, here it's wet. I know there's a lot of I&I in there. It's all collector sewers. I want to look at lining all the sewers versus a parallel system. But, oh, hey, by the way, it's, under a railroad, there's a railroad crossing, or this is a difficult area to get to along the river, something like that. That's where the constructability factor can come into play. And when you're using that, you'll have to, I think, play with the values to make sure that, it's giving you something that's appropriate there. But one thing to mention, if it's a trenchless technology, meaning we're lining these sewers, it will always default to a value of 1. Even if you have in that subunit 2 or 3, when it evaluates the trenchless I&I removal technology, it will default to 1. And this is something I learned going through this, that when you create the technology method, if it has trenchless in the name, the program will recognize that, and that will make it default to 1. So when you are coming up with these, say you're adding new technologies. Even, for instance, that manhole lining I talked about. I think in those cases, I should have named it manhole lining trenchless. It would, actually have the word trenchless in the name. Um, That's it's a subjective. Yeah,
Price that you're utilizing. In the default tab, if underneath a railroad or something like that, that the unit price that based on your experience on your bidding experience, you need to take that times 2.5 to get that bid price, that's what you put in there. It's just an ability for specific constructability issues for specific lines to elevate the cost for, special cases.
yeah. I think in the time I've been using, I've only used that a few times, the constructability factors. And I will say there's different ways to approach that in this program. Like, for instance, I would run the program with all ones there and see, all right, here's my top 5 biggest bang for the buck subunits that I can remove flow from. And as I'm going down, all right, number 3 is in this area that I know, based on this municipality and the municipal manager, that we're not touching that area, So, I could either just, all right, I'm writing this one off and go to the next one, or if I want to, show that in the actual results, that's when I'll go and say, all right, I need to adjust this constructability factor and, show that it's not feasible to do that work there. But that's what that is built in the tool for.
Just so I can make sure that the definition of constructability factor is clear. A 1 is constructible, is a range, is it a bell curve? Is it what numbers are reasonable numbers? So if you were avoiding an area because a manager didn't want you to put a project in, what would you adjust that number to?
I'd have to play with the sensitivity of it, but I think it comes down to what Jason had mentioned. If you think it's going to be 2.5 times the cost,
Oh,
I think you're basically
That's
putting
what
2.5
so 1,
in
okay,
there.
2, that's what those numbers are.
Yeah.
Since the tool's a cost or a financial analysis tool, it's not a subject number where, 2 is, or 10 is very hard.
Yeah.
Constructability.
Yeah, right.
one's very
Okay.
easy. It's okay, this unit cost is 2.5 times normal unit cost for my other subunit because it's a railroad or it's a culvert or it's the outfield at PNC or something like that.
Thank you.
When we go into the appendices, it might give us, or in the formulas, it might tell us exactly that it's, that it's the multiplication factor. This was a question we were asked previously on this percent improved main, percent improved service. So the user's guide gives the exact definition of what we're looking for there. And it's a percent number. And it's based on the percentage of land mass within the limits of the construction project. So if you're digging a trench, it's the land mass, surface land mass of that trench. What percent of that is improved area? When we say improved, it's road, driveway, sidewalk, something to that effect that requires restoration. And then similarly, and kind of harder to come up with a value for is percent improved service. And that would be, based on, your service laterals in that subunit, what percent of them are under improved surfaces, from what you know. So a lot of that, I think there's going to be a lot of estimation there. Yeah, yes, this affects your restoration costs at the end of the day when you're evaluating the different technologies. Further down in the subunit import are values for structure counts and EDUs. And it's broken down by residential, where a structure is equivalent to an EDU. So that's why there's no separate EDU value for the residential structures there. On the commercial end, one structure may equal many EDUs. And even further, we go into large commercial structures, which would be, greater than 5,000 square feet. And that there's separate EDUs for that as well. Now, we talked last time, there were questions on, what do these values represent? What do they change in the program? And, the first, on the structure end of things, each structure is going to have a lateral associated with it. So if you have a commercial structure in this subunit, it's going to assign one lateral. On the EDU end of things, from what I've, played around with to this point, the only result that's affected by the EDU number is in your infiltration tab. It gives you a base wastewater, an approximate value or volume of base wastewater. And that is determined from these EDU counts. So there's not much consequence in those values. And I would say, personally, I'm not spending a lot of time trying to, go in and figure out exactly how many EDUs are in each subunit. But you can, and it'll enhance your results at the end on the infiltration tab. So now I'm going to switch over from our main inputs to our results, and that's the 4-5 tabs in that red box there. The user guide gives a lot of detail on what does each of these mean, and I'll go into the tool itself once I get out of this presentation to show you. But there's a lot of values. There's a lot of numbers you're seeing in each one of the detail tab, the cost tab, the infiltration tab, and the user guide gives a rundown of what each of those values represents. Moving forward, further down in the user guide is Appendix G, which I find very interesting. It looks at formulas, and this gives you an idea of where each input is kind of being utilized and to get to each individual result. So there's formulas for service line linear footage. So, Glenn, I'm trying to think still on your question, how would that be applied? And it's strictly that average service lateral length versus how many structure counts you have in each subunit. Inch miles, it assumes 6-inch diameter for the laterals. Main improved cost. It's linear footage, percent improved, and then the cost for mainline improved. So these are all pretty straightforward. But if you had certain questions, you could go back into this appendix and it's going to tell you how certain things are calculated. It does appear that, subunit cost, if it's an in-trench rehab method, you're looking at mainline cost, service cost, and then the constructability factor is a straight multiplication factor on the cost. Continuing with the formulas, these results I think are in the options or the detail tab and the infiltration tab. It shows you how those are determined. And the units, which is important. I just wanted to throw this in here. There is a section on setting up overrides. And I think it gives a few examples as well. So if you are looking to override a specific subunit, and in certain cases, I would say you could also apply this to work that's already been done. Let's say I did my flow isolation results. I have the information, but I already lined this whole subunit. So I can go in and I could say, I'm not evaluating any other methodology. This has been lined. I'm just throwing it in there as such. Or if you know it's a part of an upcoming construction project, I already have it scoped out. I'm lining this. You can override that subunit. The last thing I wanted to touch on today is just the database backup. The user's guide goes through more detail than what I've shown on the screen here. But it tells you, what it is and what it isn't. The user doesn't need to go in and back up the database every time changes are made to a subunit, things like that. It's going to be built into that database you have loaded. You can save multiple databases though, and load them as such. And I think as we had talked with some of the examples, Glenn, some of your questions you had, I think you load in your base data and you can look at different results and have them already saved in certain databases that you can bring back up as you need to. So Glenn's question, and glad he presented it to me prior to this, so I was able to look into it a little bit. But basically, you have a subunit, you have your flow isolation results. So you have I that's coming from that area, but that, let's say half of it's already been lined. How do you account for that? And there's two ways to go about it. You can just have your default subunit data thrown in, as is out in the field. And when you get your results, you can modify them, manually, just basically, hey, I'm cutting this cost in half because I only need to line half the area. You can go about it that way. Or if you're going to go about it in the program, you need to adjust your subunit itself. And you can, for maybe for completeness purposes, you can leave that original subunit in and you can create a new subunit that's called, subunit A revised or subunit A 50% lined. To that, you can go to that level and show that you made that modification, which in that case I think you would keep in the I values that you got from your flow isolation measurements. You would just cut the linear footage of that pipe in half. And I guess you'd have to look at EDUs as well, or the structures as well, because when you're looking to line, you get to reinstate those laterals. So you would have to modify the subunit in the program, I think is probably the more appropriate way to do it. Any other questions? Okay, well, I hope you guys are able to start using this program and going through and getting questions if you have them, because I think we are probably have maybe one more session planned specifically on CEP. And then, as always, you can just email any questions you have to Annie and she can get them distributed. But that's all I got.
I guess, Jake, one thing that, just from what I'm hearing from you, it sounds like there's a lot of options within the tool. Obviously, there's a good side and a bad side to that. One is, it's not gonna be some things aren't well defined because you're just given flexibility.
Yeah.
But it does give you those options, and I think you mentioned sensitivity analyses and things along those lines. I think that's a great way to go through that, before you go too far in creating other areas. You can kind of run some of those sensitivity analyses to see, is this really gonna even make a difference? It does. Then I think there's some flexibility built into the tool to figure out a way to try to account for those.
Yeah.
And I think if you identify those as you're working through your setup, maybe bring some of those back to us, because we can, it's not to account for some of those things. It's not this is the only way to do it. There's probably multiple ways. And maybe some ways that you figured out would be useful for everyone else as well.
Absolutely. That's a good point. Yeah. Lessons learned. Yeah. On top of questions and, anything you were able to figure out or ways you were able to use the program and, in special cases, certainly is going to be helpful to the group.
Thanks, Jake. What I was thinking when I'm sitting here listening to this was, look for an email. I think what I'm gonna have you do, you gotta use it. You have to start putting your scenario into it. And I think what we're gonna do is open up a time. I'm gonna work with Jake and say, okay, here's a time, and we're gonna have it, Jake help time. That you can, just say, okay, I have this specific problem right now. And, we'll open up a time, maybe, Jake, send you a Teams link or whatever. We'll have something. You go on, you kind of work through it. Jake might ask you to record it or whatever, so that we can bring it back, or Jake can walk through it for real scenarios. But that way, if you have it, we'll call it the Jake help time. And we'll set certain periods of time that he knows in his schedule, people are going to call me for CEP. I think that might work better to get people on these one-on-one. Then Jake will get a handle on what is the issue.
Yeah. Right.
Instead of coming here, because it seems like people haven't used it enough yet, or you're shy. But I've never known this group to be shy. So that's what's I'm thinking it's either working or people haven't got into it enough. But I'm thinking this Jake help time might be the way to go. So thanks again, Jake. I think it was informative. It starts people walking through.
We did want to take a bit of a head count, so I already asked online and people are replying, but how many of the people in the room have downloaded the tool and could access it to begin the process?
Confirm that.
Yes.
Brad, you
a
haven't
couple
used the
more.
tool?
Yeah, you're on today's call. Soon.
Yeah, so thank you. Next week is the combined SOAR meeting. And it is going to be on,
The approaches for modeling source reduction in according to the GROW program.
that's right. We have our friends from Elcasan coming to the meeting. They're going to talk about the modeling sources for the GROW grant and things that have worked. Like this kind of project worked better than other projects. So next week is Elcasan. So thank you. And yes, Glenn's question was, are we going to get into how we put in the source flow reduction into the model? And yes, I'm understanding that is going to be part of the project. Okay, thanks, everyone. Go out and enjoy the rest of the sunny day, a non-wet weather day. So thank you.
Thanks.